In the previous videos, we discussed whole life assurance, okay, its expectation and variance. Similarly, we discussed term assurance, endowment assurance, and pure endowment assurance. Okay, we covered expectation and variance of all of this. All right. Now, in this lesson, our focus is on deferred assurance. Now, this is not a completely different type of assurance, but this is just a concept that we should learn. So let's take an example of whole life assurance, deferred whole life assurance. So the present value of deferred whole life assurance is when kx is less than n, this is 0, and when kx is greater than or equal to n, this is v to the power kx plus 1. Now, if you do not remember what is whole life, let me help you recall. Suppose you buy the policy at age x. So from here, your whole life will be assured. Now, in deferred whole life assurance, suppose you buy the policy at age x. So up until n years, so in this duration, if you die, your nominee will not get the benefit. Okay. So you must die after x plus n in order to get the benefit, that is death benefit. Okay. So this is n year deferred. All right. So if you look at the present value, you can see when kx is less than n, what is kx? Kx is the number of integer years that a person will survive after age x. Okay. So when kx is less than n, the present value is 0. Okay. And when kx is greater than or equal to n, the present value is v to the power kx plus 1. So now, using the basic idea of expectation, we can calculate the expectation of the present value. Summation k goes from 0 to n minus 1. Present value is 0 times PDF kx equals to k, plus summation k goes from n to infinity v to the power k plus 1 PDF, or probability in discrete. So now this expression is 0 plus Vn. Okay, if you put the value, this is Vn n px and ax plus n. So you can expand this, and then you will see that you can take Vn n px common from that expression, and the remaining expression will become ax plus n. Okay, so you can expand this. All right, and we can write this as n deferred ax. This is the whole life assurance, and this is deferred by n years. Okay, so from here we have whole life assurance, and this is simply deferred by n year. So this is the notation. All right, now if you remember, the term assurance is ax minus vn n px ax plus n, right? Or we can understand this as, suppose you buy the policy at age x, and this is whole life assurance. So from here your whole life will be assured. Now you want to find the term assurance for n years. So suppose this is x plus n. So how would you find out? Now from here you have the whole life assurance, right? So from this point you can again take the whole life assurance. Okay, so you have to survive this duration, and since you are calculating the present value, so you need to discount this Vn n px, and from here you have the whole life assurance ax plus n. Now from this whole you can subtract this segment, right, to get the term assurance. So this is simply ax minus this term. Okay, this is how you can obtain the term assurance, right? So from here we can say that term is nothing but whole minus deferred. This is basically deferred, right? So we can conclude that term is whole minus deferred. So we can say that present value of deferred is present value of whole minus present value of term. Okay, now using this idea we are going to calculate the variance of deferred. Okay, so the variance of present value of deferred is variance of present value of whole minus present value of term. Now if you remember the variance formula, x plus y, this is, okay, let me write minus, so this is minus, or you can write variance x plus minus y. Okay, this is same. So the variance of x plus variance of y minus 2 times covariance of x comma y. Okay, so this is the formula and we are going to use this to calculate the variance of present value. So here we can write variance of present value whole plus variance of present value term minus 2 times covariance of present value whole present value term. Okay, now we know the present value variance of the present value of whole, and this is this as well, so we need to calculate the covariance. So the formula of covariance when x comma y is given, this is expectation of xy minus expectation of x expectation of y. Okay, so we'll be using this formula. So the covariance of present value of whole present value of term is expectation of present value of whole and present value of term minus expectation of each. Okay, now if you remember, the present value of whole is v to the power kx plus 1, right? Now can I write this in the form v to the power kx plus 1 when kx is less than n, and when kx is greater than or equal to n, this is again v to the power kx plus 1. So this is same, right? Now multiplied by present value of term, which is v to the power kx plus 1 when kx is less than n, and when kx is greater than or equal to n, this is simply 0. So this term will be 0, right, multiplying with this term. So the present value of whole times present value of term is v to the power 2 times kx plus 1 when kx is less than n, and when kx is greater than or equal to n, this is 0. Okay, so from this we can say the covariance of present value of whole and present value of term is the expectation of these two minus the expectation of each. Now the expectation of this term is nothing but 2ax dash n minus the expectation of present value of whole is ax times expectation of the present value of term is ax dash n. Okay, now we can calculate the variance of the present value of deferred. This is the variance of the present value of whole, that is 2ax minus ax whole square, plus the variance of present value of term, that is 2ax dash n minus ax dash n whole square, and then minus 2 times covariance. So this whole expression, so 2ax dash n minus ax dash n. All right, now let's simplify this little bit. So this is 2ax minus ax whole square plus 2ax dash n minus ax dash n whole square minus 2ax dash n plus 2 times ax dash n. All right, so now this is 2ax minus, because we have here 2 minus term and here 1, so this is minus 2ax dash n, and then minus, we can take minus common from this term, and from this term. Okay, so this will form a minus b whole square. So I can write ax minus ax dash n whole square. So this is 2ax minus 2ax dash n, and this is nothing but the deferred, so minus n deferred ax whole square. Okay, so this is how you can derive the present value and expectation of present value and variance of present value of deferred whole life assurance payable at the end of year of death. Okay, so now let's look at payable immediately on death. So deferred whole life assurance payable immediately on death. So the present value of deferred will be when tx is less than n, this is 0, and tx is greater than or equal to n, this is v to the power tx. So now we can write the expectation of the present value is, since less than n is 0, so we can start from n to infinity, because the range of t is from 0 to infinity, right? So this is vt tpx mu x plus t, this is the PDF, and dt. We can integrate this, we'll get vn npx a bar x plus n. Okay, you can substitute t equals to s plus n and then s equals to t minus n, then you can change the limit, and this is ds equals to dt. This is how you can integrate, you will basically arrive here. Okay, so now we can write this as n deferred a bar x. Okay, now the variance of the present value is 2ax. You can derive this on your own, I'm just going to write the result directly, minus 2a bar x dash n minus n deferred a bar x. All right, so this is all about whole life assurance, deferred whole life assurance. Now let's look at deferred term assurance. Deferred term assurance payable end of year of death. Okay, so the deferred period is, let's say, n years, and the term assurance is, let's say, m years. Okay, and sum assured is 1 unit issued to a life is x. Okay, so if you understand this from the number line, suppose this is x plus n, this duration is deferred, and this is x plus n plus m, so this is term assurance from x plus n. All right, so the present value is when kx is less than n, present value is 0, and when kx is greater than or equal to n but less than m plus n, this is v to the power kx plus 1. You can understand this from the number line, and when kx is greater than or equal to m plus n, this is 0. Okay, now the expectation of the present value is, you can answer this from the logical reasoning as well. So the n years is deferred, right? So vn npx, we have to survive n years, and then from x plus n you have the term assurance for m years. So you can write from x plus n, this is term for m years. Okay, so this is the deferred term assurance expected value, or you can write n years deferred term assurance. Okay, if you want to derive this from the first principle, you can do it. Okay, so now let's do for the immediate case, immediately on death. So the present value will be, when tx is less than n, this is 0. When tx is greater than or equal to n but less than m plus n, this is v to the power tx. And when tx is greater than or equal to m plus n, this is simply 0. So the expected value is, again, n years is deferred, so vn npx, and then for immediate case we write a bar and then the term x plus n for m years. Okay, so basically you can predict these results based on the previous concepts as well. Okay, or we can write this as n deferred a bar x dash m. All right, if you want to derive this, you can go from the first principle. And now for variance, we are not going to derive or write the result for the variance because that's too complicated and we are not going to use that while solving the questions. Okay, so let's not bother about the variance of deferred case. And this is all about the term deferred term assurance. So now let's stop here and I'll see you in the next video. Thank you so much for watching this video.